Welcome to the course module of Communication Engineering. And in this video, we are going to learn about the statistical averages of random variables. So let's begin this discussion. So the first statistical average that we are interested in the case of random variables are the averages or mean value, or it may be called as the expected values. Okay. So try to consider this example. Suppose we are having a class which consists of 100 number of students. Okay. So if we measure the height of the students, okay, in inches, then obviously because all the 100 students would not have the same height, it may have a different heights. Okay. So suppose that if we denote the height by using the random variable capital X, then the outcome of each measurement will be denoted like this. Okay. So there may be a student could have the height equals to x1 inches, it could be x2 inches, and it could be up to xn inches. Okay. So it can have a different height. Okay. So there may be a possibility that there will be n1 number of student may have the same height x1. Okay. Similarly, we can have n2 number of student, they may have the height equals to x2. And similarly, we can have the nn number of the student who are having its height equals to xn, right? So this way, we can have this particular height distribution, right? So now, if we want to ask, suppose that what will be the average height of the class? Okay, I can ask you this particular question. Then how to get this average height? Okay, so if we want to get the average height, okay, then this is called as average, or you can say it is what is the mean value of the height, or it can also be called as the expected value of the height. Okay, so normally this will be represented by x bar. This will represent you the average of this particular height. This can also be written as this particular operator E, which is called as the expectation operator. Okay, so this will be represented as expectation of this random variable x, right? So if we do this measurement, then what will be the expected height? So that denotes you the mean value or average value, right? So that we can obviously calculate by calculating these numbers, right? We have to calculate how many students are having x1 height. So that will be n1 multiplied with x1. And then similarly, we have to do this calculation up to your xn, right? So we have to calculate this heights, okay, multiplied with the number of students, those who are having this height. And then we have to multiply all these numbers, right? And then we have to add these all numbers, right? So after adding these numbers, we have to divide this entire summation by the total number of students. Okay, so this way, if we do, we are going to get the average value of your height. Fine. So now if you rewrite this expression in this form, if we write n1 divided by capital N multiplied with x1, plus again, if we write this way n2 by n multiplied with x2 up to this number, then you will find that this particular ratio n1 by n represents you the probability that it is denoting you the probability that the height will be x1. Okay, because we know that in the case of probability, the definition of probability says it is the number of favorable outcomes divided by a total number of outcomes. So because this capital N represents the total number of students, okay, and this this particular n1 represents you, it is the number of students which are having height equals to x1, right? And therefore we can write this particular ratio as the probability of finding this height equals to x1. So similarly, you can also write here, this will become the probability of having the height equal to x2, and this will represent you the probability of having height xn, right? So this way we can rewrite this expression. So this expression will be transformed into this. So here you can see this expected value or mean value of your height x bar could be written as x1 multiplied with probability of x1, similarly plus x2 probability of x2, and up to xn probability of xn. Okay, so just make this correction, it should be xn. Okay, so this way we are going to get this average or mean or expected value of your height. So this equation can be applied to any discrete random variable. Fine. So here we know that because these outcomes are your discrete numbers. Okay. And therefore, I will call this random variable as a discrete random variable. And this can be written in this compact notation. If we wish to calculate the mean value of any discrete random variable, then this can be calculated by using this formula. Okay, so this formula is I equals to 1 to up to small n, and then we have to multiply the value of xi with its corresponding probability. Okay, if we do this multiplication and if we sum it up to variable n, then we are going to calculate the expected value. The similar idea of calculating the average, mean, or expected value for continuous random variable can also be calculated by having this equation. Okay, so if suppose that if we have the random variable to be a continuous random variable, in that case, this formula will be converted into this formula. Okay, so here the summation will be converted into the integration, and this integration will be going from minus infinity to infinity, or depending on what is the range. So normally we know that because here this probability will be converted into the probability density function, and this is the corresponding values of your random variable. So this way, this formula will be converted into this way. Okay, so this particular formula. So for continuous random variable, we can calculate the mean value or average value by following this particular equation. Remember that here it is a probability density function instead of probability, right? So now we can see another statistical averages, which is known as the moments. Okay, so normally the nth moment of a random variable x is defined by this particular expression. Okay, so here this particular expression represents you the nth moment. It is x to the power n, the mean value of the x to the power n. Okay, so that is defined as it is this integration from minus infinity to infinity, and x to the power n. Okay, x to the power n, and pxx into dx. So you can see that if we talk about the mean value, then obviously that time this n will become 1. So that is the first moment of your random variable x. So if we talk about the mean of your continuous random variable, that time this n value will be equals to 1, and that time this results will give you mean value. Similarly, we can also have the nth central moment. Okay, so this nth central moment is actually being defined by this particular expression. So here, from the random variable x, we have to actually subtract the mean value, right? X minus x bar. We have to subtract this mean value. Then there will be a power of n, because we are calculating the nth central moment. Then we have to take the mean value, right? So this is our minus infinity to infinity. Integration should be from minus infinity to infinity. And here this number will become x minus x bar to the power n. And here is the probability density function. So this way we have to calculate your nth moment or nth central moment. So normally one of the very important parameter, which is your second central moment. Okay, this parameter is very much useful while discussing the random variables, or even in the random process. Okay, while discussing about the noises. Okay, so in the most of the noise calculation, we use this particular second central moment. So this second central moment of a random variable x, which is also called as the variance. Okay, so this is also called as variance, and it is defined by sigma x square. Okay, so this is the standard notation of your variance, sigma x square. Okay, and it will be the expected value, means expected value means it is the average. Okay, you remember that we are calculating this bar, so that bar reflects to the average value, right? So we are calculating the expected value of x minus x bar to the power 2. Okay, because we are calculating the second central moment, so this n will become 2, right? So this way we have to calculate our variance. So if we expand this expression, okay, here this expression can also be further be written as x minus x bar whole square a whole bar, right? Because we are calculating the mean value, right? So now if you expand this expression, here we can write this expression. If you expand this square, you will be able to write this will be x square minus x bar whole square minus x square plus x bar whole square minus 2x into x bar. Okay, so basically what we have to do is you have to just expand this expression by just following the a minus b whole square formula. So that will become a square minus 2ab plus b square. And after that, this bar, if you apply, then this bar will be, you remember, if we have a minus b whole bar, then it can be equals to a bar minus b bar. Or if it is a plus b bar, then this will be becoming a bar plus b bar. Okay, so that bar will be applied to the each or individual terms, right? So that I have already done here. Okay, it is x square bar then minus 2x into x bar whole bar plus x bar square. Okay, so here one thing that we can understand is 2 is a constant, so we cannot calculate the average value of any constant. Similarly, if you see this x bar, okay, so whenever we have x bar, this x bar represents you a particular constant value, right? So again, this will be also treated as a constant, so this will also come out of the bar. Okay, so we cannot calculate the mean value for this particular x bar, right? So here, if we take it out, we can write 2x bar multiplied with the x bar. So here it will become 2x bar square. Fine. So this way it will become 2x bar square. So here we have another x square, x bar square. Okay. So now if you solve this, we will be able to show that it is x square bar minus x bar square. Okay. So this is the standard equation for calculating the variance or second central moment. Okay. So if you want to write this into word, then we can write this variance is nothing but it is the mean square value. This is the mean square value. Okay, so we are calculating the mean of the squared value. Okay, minus a square of the mean. Okay, so we are calculating the mean and then we are squaring it. Fine. So this way we are actually calculating the variance. So variance is equals to mean square value minus a square of the mean. So try to again understand what is mean square value. We are calculating the a square first and then we are calculating the mean. So that's why we are writing it is the mean square value. Okay, it is the squared value ka jo mean hai, that we are calculating here, right? And here it is the square of the mean means first we are calculating the mean and then we are squaring the value, right? So now here you can see this is the standard deviation. Okay, so standard deviation will be equals to root over the variance. So normally if we know the variance, we can easily calculate the standard deviation by just taking the square root. Okay, and that will be denoted by the sigma x, right? Now again, we have to see if suppose we are having the some independent variables. Okay, so if we have certain independent random variables, then how to calculate the variance if we summing the two independent random variables. So let's suppose that we are having two random variables x and y, which are independent to each other, right? So when these two random variables are independent to each other, and suppose that I'm generating another random variable by using this two random variable. So suppose that if we are summing this two random variable x plus y to generate a third random variable, which is z. Okay, then obviously if I ask you what is the mean value of this random variable z, okay, so in that case, obviously, when you calculate the mean of your z, then you can apply the mean to this particular sum. So it will be x plus y whole bar. So generally, if this number is x plus whole bar, then it will be equals to x bar plus y bar. Okay, but here we are interested in calculating what will be the variance of the sum of the independent random variables. Okay, so if we have the sum of the two independent random variables, then what will be the variance? So in such case, we have to use again this particular equation. Sigma z square will be z minus z bar whole square to the bar. Okay, so we are just following this particular expression to calculate the this particular variance, okay, of random variable z. So if you expand it, okay, in terms of x plus y, so you just substitute z equals to x plus y. So this is your minus sign, and then again this z bar, if you write, because it is a mean value, okay, mean value of this z. So if you write, this will become x bar plus y bar. Okay, So here I have written it as a x bar plus y bar. So again, I can rewrite this expression. I can write this expression as x minus x bar, then plus y minus y bar. So try to just rewrite this expression. I am taking these two variables together, x and minus x, x and minus x bar together, and I'm writing this y minus y bar together. Okay. And then if you expand this expression, we will be able to write this. Okay. This expression will be x minus x bar whole square plus y minus y bar whole square plus 2x minus x bar into y minus y bar. So now here I will be using this property whenever we have the independent random variables. In the case of independent random variables, a and b, if we are calculating the mean of the product value of the two random variable which are independent, then this will be equals to the product of the two independent, these two separate means. Okay, so a b bar is equals to a bar dot b bar. Okay, so this will be the property. Okay, if we are having the independent random variables, right? So this same property I have to use here. Okay, so this same property we have to use, right? So this property if we use, then you will be able to write this expression. This will be x minus x bar whole square bar plus y minus y bar whole square bar. And then this will be written in this form, x minus x bar here multiplied with y minus y bar here, right? So now if you take this bar, okay, so if you apply this bar to this random variables, here we can see again it is two numbers, right? So here this x bar represents to a constant value, right? So even if you write x bar, it means that it is x bar only, right? Because suppose your mean value is, let us say, 2.5, then if you calculate mean value of 2.5, doesn't make any sense, right? So again it will be 2.5 only. So therefore, this will be treated as a constant x bar, and here again y bar will be treated as a constant. So here, if you apply the bar over this x, okay, this will become x bar minus x bar, and here it will become y bar minus y bar. And that time this x bar minus x bar will be cancelled out. And this entire term will become zero, right? So ultimately, we are left with only this term and this term, and this term reflects you the variance of your random variable x. Okay, here you can see that it is x minus x bar whole square bar. So therefore, this will represents you the variance of your random variable x. Similarly, this represents you the variance of random variable y. So ultimately, we are going to get this particular expressions. Okay, so here is the next step, and then finally you are going to get this particular expression. So the meaning is, if we have two independent random variables, and if we sum this two independent random variables to get the another random variable z, then the variance of this random variable z will be equals to the variance of it will be equals to the summation of variance of the individual random variables. Okay, so this sigma z will be sigma z square will be equals to sigma x square plus sigma y square. Okay, so one more thing, if suppose if we want to get this value, okay, z square bar. Okay, so here you try to understand this value and this value is two values are different, right? Here we are calculating the this second central moment. Okay, you remember this represents your second central moment, right? So we can also calculate the second moment. Okay, we can directly calculate the second moment. So if we calculate the second moment, we have to follow this particular formulas, right? So these formulas we have to actually follow, right? So here you can see this. Okay, if we follow this particular formula, normally we can again go by this definitions only, right? Here we have to just write z square bar, and then you have to write this number x plus y, then square, and then we have to apply the bar, and then again we have to follow the similar procedure. Okay, and remember that if this mean values of x and y is 0, then this value will be equals to x square bar plus y square bar. So remember this mean square value will be this particular formula. Okay, provided that the mean of x and y is 0. Okay, if this is the condition, then you will be able to show that this second moment, okay, this second moment of your random variable z will be equals to the individual second moment of random variable x and y. So this is the another relationship, right? So now we can see there is a mean of a function of a random variable. So what does it mean by mean of a function of random variable? So that we try to understand in this problem, okay? So suppose that we are having a random variable x, okay? We suppose that I have a random variable x and whose mean is represented by x bar, okay? Then I can have another random variable y, okay? Which is the function of the first random variable, okay? So it is some function gx of your random variable x, right? So this may be like y is defined as equals to x square, okay? So if we define this random variable y, then I can say that it is a some function of x, right? So just for the simplicity, I have just taken x square. It could be any other function of x also. Okay, you can write like x cube plus x square plus 1 or something different forms. Okay, you can write like that. Okay, so here what I like to tell is that because this is your another random variable, but this random variable is a function of some other random variable x, right? So now suppose if I want to calculate what is the mean of this random variable y, then obviously we have to take the mean of this function gx. Fine. So because this function gx is x square, I will be interested in calculating x square bar. Okay, so this will be representing you the mean of your random variable y. Fine. But here you remember this for this particular random variable x, the mean is x bar. But for this particular random variable y, the mean value is x square bar. Okay. So here if we take any discrete random variable x, suppose, okay, I have already explained in my first slide that if we have any random variable, any discrete random variable x, and if it is taking the values like x1, x2, xn with the probabilities of px1, px2, pxn, okay, then the mean can be calculated by following this particular formula. Okay, I have already discussed in my first slide. But suppose if it is a function of gx, okay, suppose that if we have a random variable y, which is a function of gx, and if it is taking the values like gx1 and gx2 and gxn with the probabilities of x1, px1, px2, pxn, then obviously this formula will be actually converted into this one. Okay, so here because I was writing x1 directly, this is xi directly, because at different values of I was having a different values of x. Okay, but here because we are putting these values of I, then this will be substituted into this particular function gx. Okay, and therefore I'm just writing what is the value of this particular function gxi. Okay, so here this formula will be just, there will be a little bit change. It will be a function of gxi, and then again it will be pxxi. So this way this equation will be converted. Fine. Now I can also write this similar expressions for your continuous random variable. Okay, so in that case, if this y is a continuous random variable, x is also a continuous random variable. In this case, this mean value can be calculated by having this particular integration minus infinity to infinity. Instead of just having xi here, I can write this function itself as gx. Okay, so gx multiplied with the probability and density function pxx dx. So this way we can calculate this mean value where this particular random variable y is the function of some another random variable x. Fine. Now I will show you one example so that you will be able to follow this all whatever I have explained till now. Okay. So let's consider this problem. Okay. So suppose the output voltage of a sinusoid generator is A cos omega t. Okay, so this output is sampled randomly. Okay, and the sampled output is denoted by a random variable x. So here it is mentioned that we are having a sinusoidal sinusoid generator. So here we have the sinusoid generator. This is a sine wave generator. Okay, and its output is actually being denoted by A cos omega t. So it is at this two terminal. It must be generating a sinusoidal waveform of a certain amplitude A with a certain frequency omega. Okay, so it is a cos omega t waveform will be available at this particular point. Okay, this particular terminal, and here we are actually sampling this output. Okay, so at a random instant of time t. So these sample values are actually denoted by a random variable x. Okay, so this sampled output is actually being denoted by this random variable x, which can take on any value in the range minus a to a capital A. Okay, so this minus a to a, we know that because it is a cosine function, it will be varying from minus a to a, right? So now we have to determine the mean value of this sampled output x and the mean square value of the sample output x. This is what we have to calculate. So here one thing is very much clear that here the sine wave generator is going to generate the cosine waveform A cos omega t. And this output is actually being denoted by xt. Okay, so this xt is nothing but your A cos omega t, and we know that because t is a random instant of time at which we are actually doing the sampling, right? So because t certain a random instant of time, then obviously the output x is going also to be a random signal, right? So this value is going to be a random signal. Now here you can write this expression A cos omega t, and we know that because at the random instant of time t, this omega t will be a random value. Okay, so let us suppose this omega t, we are denoting it by theta, and obviously when t is a random time instant, then this omega t is also going to be a random signal. So this theta is random signal. Okay, so when this theta is also a random variable, if we say, then what will be the range of this value of theta? Okay, so when this time progresses, we know that generally this theta can be, suppose it can go from 0 to 2 pi. Then again, it can be something greater than 2 pi. It may go to 3 pi, 4 pi, okay, or somewhere 5 pi, 6 pi. It may be something else, okay. But normally we know that because the cosine or sine functions normally it is having different values in between 0 to 2 pi only. And after that, it will start repeating its cycle, okay. So if we have this theta values from 0 to 2 pi, and let us suppose if we have 2 pi plus certain angle 45 degree. At that case, this 2 pi plus 45 degree can be written as cos 45 degree. Okay, so we already know that this formula cos 2 pi plus theta will become cos theta. So therefore, what we can say that this theta can have its range from 0 to 2 pi only. Okay, so because this theta can take any value in between 0 to 2 pi uniformly. Okay, so there is a uniform distribution of this value of theta. Okay, so because it is having the uniform distribution of value of theta in between 0 to 2 pi, then I have already discussed about the uniform probability distribution. Okay, so in that case, here we can denote this is the value of theta, which is being varying from 0 to 2 pi. And if this is the uniform distribution, then this should be a constant value, okay? And we know that if this is the uniform probability distribution of your probability density function of your random variable theta, then the area under the curve should be equals to 1. Okay, so we have to integrate this probability density function of your random variable theta with respect to 0 to 2 pi d theta, then this area under the curve should be equals to 1. So ultimately we are going to get this p theta will be equals to 1 by 2 pi. So this probability density function for your random variable theta, which is having uniform distribution, is going to have this particular constant value 1 upon 2 pi. Okay, so obviously because this width is 0 to 2 pi, so its width is actually 2 pi. So this height should be equals to 1 upon 2 pi, so that this area of this rectangular strip is going to be equals to 1. So this way we have this probability density function, okay, of random variable theta. So what I can say here is that this random variable x, okay, this random variable x is a function of another random variable theta. Okay, so this random variable x is actually depending on the distribution of your random variable theta. So if I want to calculate this mean value x bar, okay, So that time what I have to write is I can write this, I can integrate this based on the distribution of your theta. So because theta is being varying from 0 to 2 pi, and then it should be multiplied with the x multiplied with the p theta, theta d theta, right? So what is this x? This x will be your a cos theta, okay? And here we have to substitute for p theta theta. So this is your probability density function, so that you can substitute as equals to 1 by 2 pi. So now we can integrate this value, because if we integrate any cos function or sine function in a complete period, then this value is going to be 0. So here we can see that the mean value of any cosine function is 0. So here we are getting this mean equals to 0. Similarly, we can also calculate this mean square value. Okay, so if we want to calculate this mean square value, then again we have to follow the same formula. This integration should go from 0 to 2 pi. Then here we have to substitute x square p theta we have to write here. Then there you can substitute this value x square. This x square will become a square into cos square theta, so that we can write here a square cos square theta. And then we have to substitute this probability density function, which is equals to 1 by 2 pi. Okay, so it will come out of the integration because it is a constant. So if you do this integration, you will be able to show that this result is coming out as a square by 2. So this way we can solve such problems. Okay. So I hope you must have understood how to solve such problems. Okay. So we'll stop here today and then we discuss some other topic in some other lectures. So thank you for watching this video. If you having any queries, then please let me know with your comments. Thank you.